So we're going to talk about statistical paradoxes. And we don't have a lot of problems in this one. We just have a couple. So the first question is, who played better? So we have a table here that gives the shooting performance of two players in each half of a basketball game. Cheryl had a higher shooting percentage in both the first half and the second half. Can Cheryl claim that she had the better game? All right. So we're going to have to look at this by looking at the overall game statistics. Now, we can see that Cheryl had 40% and 75%, and Candace had 25% and 70%. So she's beat her in both of the categories, but overall we've got to look at what's going on. All right, so we've got, let's see, this is 4.4. Example 1, we have Cheryl. And we have Candace. So Cheryl, in the first half, she made 4 baskets. And in the second half, she made 3 baskets. So she made a total of 7 baskets. So 4 plus 3 gets us 7, right? And out of that, how many shots did she actually make? She made 10 shots and she made 4 shots. Sorry, I'm a little slanty over there. So 10 plus 4 will get her a total of 14. Well, if we do the math on that, that's 7 is half of 14, and we change it to a percentage, so we would get, this would do in a calculator, if we pull our calculator out, we'd get 0.5, right? So we're just going to, again, throw it in. So 7 divided by 14 gives us 0.5. But we want it in a percentage, so if we multiply by 100, we'll get 50%. Okay? Now, let's look at Candace. Candace only made 1 basket in the first half, and she made 7 baskets in the second half. So she made 1 plus 7, which will get her 8 on the top. She made 4 attempts in the first half and 10 attempts in the second half. So she's got the same denominator, right? Well, when I put that in the calculator, I get 8 divided by 14. This is going to get us like 0.57. And then there's a 1. So we'll go to like 3 on this one. The other one was just 0.5. So, and then if we multiply that by 100 or move our decimal place over 2 places, we get 57.1%. Now, Cheryl did better in both quarters than Candace, but overall, out of the number of attempts made, Candace actually had a better record. So Candace is better overall. So this is why it's called a paradox, because it looks like straight cut, right? She's doing better. She's a better player, but actually Candace made better basket percentage overall. All right. So you just got to be able to put the pieces together over the denominators and then figure out the percentage and then compare them. So example 2, we are at doesn't make sense again. So Sue wins each of the first 2 sets of a tennis tournament by winning more games than her opponent in the first set, and also winning more games than her opponent in the second set. It follows that Sue won more games than her opponent in the first 2 sets. So, does this make sense? So, it's not like she made it's not just the number of baskets. So on the previous one, it was just the number of baskets, but we didn't look at the total attempts, right? So we were just looking at how many baskets did you make. Well, she made 4, she made 3, she made 1, she made 7. But here it's saying that Sue wins each of the first 2 sets of a tennis tournament by winning more games than her opponent. So she won more games here. So you're already looking at those. She won more. The opponent won less. And she did the same thing. She won more in the second set as well. So it looks like Sue won more games. So it follows that she won more games in total. And that does make sense. So let's give that a little bit of wording. The sum of wins, because they're adding up the number of wins for Sue, is going to be greater than the sum of wins for her opponent. Okay? So, because you're already summing them up and you're not just comparing them in percentage-wise, it clearly states she won more games than the other person. So it's a sum. It's not the percentage. So that's a little bit of the difference between those. And so make sure you do your homework on this. And this is kind of like a short section, but keep up on that homework.